In this video, we're going to look at Chapter 18, Section G, on angle formula. And the first thing that we're going to do is draw a unit circle. From here, I'm going to draw 2 points on the unit circle. The first will have a positive angle theta, and the second will have a negative angle theta. Now the magnitude of these two angles is the same. And we'll draw their points. The first one has a point P, and we know that its coordinates are cosine theta and sine theta. And we have another point, point P prime, we'll call it, and it has coordinates of cosine negative theta and sine negative theta. Now we know from previous studies that because these 2 points are in the first and fourth quadrants, that the cosines are going to be equal here. And we know that the sines are not equal, but they are negatives of each other. So the negative of the first sine, or the first y-coordinate, is equal to the second y-coordinate. And that allows us to write a relationship, which I'll define on the next page. Let's draw another unit circle. And again, we're going to draw a few points, but first I'm going to draw the line y equals x, which would split the first and third quadrants, and that the angle of that line would be 45 degrees, right, or pi over 4. Now let's draw 2 other points. My first point P, which again has the coordinates cosine theta, sine theta, and P prime. And let's define a few things about these angles, or these points. The first one is formed by an angle theta, and the second one is formed by an angle of 90 minus theta. Right? So these two angles right here are equal, and that would make the second angle 90 minus theta. So you can see that the coordinates of P prime are going to be the cosine of 90 minus theta and the sine of 90 minus theta. And again, we can see some relationships here. And these relationships are probably best illustrated with an example. So let's say that theta is 30, which would make 90 minus theta 60 degrees. And from our previous studies, we know that the cosine of 30 is going to be 1/2, and the sine of 30 is going to be square root of 3 over 2. And likewise, we know that the cosine of 60 is going to be the square root of 3 over 2, and the sine of 60 is going to be 1/2. Notice that the coordinates of these 2 points are simply flip-flopped, and that's because they're reflections of each other across this line y equals x. This will actually hold true for all complementary angles. In other words, the cosine of theta is going to be equal to the sine of 90 minus theta, and vice versa. The sine of theta is going to be equal to the cosine of 90 minus theta, and this will always be true. And again, I'm going to write these relationships on the next page. So here are the relationships that we've defined so far. Cosine of negative theta is equal to the cosine of theta. the sine of negative theta is equal to negative sine theta. And we saw this from the first unit circle. From the second unit circle, we found that the cosine of 90 minus theta, 90 degrees, is equal to sine of theta. And the sine of 90 degrees minus theta equals cosine of theta. And this follows because these two are in degrees, so we can rewrite these in radians. Right? So cosine of pi over 2 minus theta is equal to sine theta. And the sine of pi over 2 minus theta is equal to cosine theta. And these are really just the same two relationships, except these two are for radians and the first two are for degrees. Now let's take a look at a few examples. Our first example is 5 sine theta minus 2 sine negative theta. What I'm looking to do here is simplify. The first thing that I can notice or recognize is that I have a sine of negative theta here. Well, from our previous slide, I know that sine of negative theta is really equal to negative sine theta. Once I see that, I know that I have 5 sine theta plus 2 sine theta, right? Negative 2 times negative sine theta is really a plus 2 sine theta. And the last step is quite straightforward. I have 7 sine thetas, and that's my simplification. In my second example problem, I have 4 cosine of pi over 2 minus theta minus 3 sine theta. Well, remember that the cosine of pi over 2 minus theta, this is really like cosine of 90 minus theta, can be rewritten as simply sine of theta. And once I know that, again, the last step is fairly straightforward. I have 4 sine theta minus 3 sine theta, which leaves me with 1 sine theta. So the key to these problems is really finding the term that you can change and seeing which one is most beneficial to change so that your multiple terms now simplify into less terms.